This video is to teach you guys a little bit more on sampling. There are some things in the AP syllabus that are not explicitly taught in the book that has to do with sampling. And so to teach you those things, I've made this small video just to teach you a few things about sampling that you should know. The first thing about sampling I want to talk about is bias. Now, bias results from a sample not being representative of the population. So, something that you have to realize about getting a sample from a population is no sample is going to be perfect. The population is the population. That's what we're trying to figure out. But using statistics, we often only have resources to look at a small sample or maybe even a large sample. And the population is normally so big that we don't have the resources to analyze every single element in that population. So we just get a sample of those elements, and that gives us a good idea of what the population is. But it's not perfect. So the difference between that sample and what's actually going on in the population is known as bias. And there's some popular ways that bias can result when you're sampling. One common thing that often comes up on the AP exam is something called voluntary or volunteer response bias. And there's several AP questions in the past that have dealt with this. Voluntary response bias is simply, if I want to survey people or something like that, the volunteers will respond to it. Okay? So for example, let's say I want to know about the lunch program at the school, the cafeteria food, let's say. So what I'm going to do is I'm going to send out a letter to all of the students at CHS, and I'm going to have a survey inside. And I expect them to respond to that survey. Well, who's going to respond to that survey? The people that probably have really strong opinions. So if someone has a really strong opinion, maybe they really like the cafeteria food, or maybe they don't, and despise the cafeteria food, those people are probably going to be more likely to respond. If I'm indifferent, or if I really don't care about the survey because I don't want anything to change, I'm probably not going to respond to the survey. This is a major source of bias when it comes to sampling. So we want to try to eliminate voluntary response bias. To eliminate voluntary response bias, some things you can do is perhaps have a small reward for turning in the survey, or maybe give a survey at a point in time where people won't often refuse, such as right after they buy food from the cafeteria, for example, and you talk to them in person. People are more willing to talk to someone in person if someone confronts them than just throw away something in the mail. Okay? That brings us to non-response bias. Let's talk about non-response bias. Non-response bias is kind of the opposite of voluntary response bias. It occurs when people or a large percentage of the population don't respond to a survey that you might be giving out. So let's go back to the mail example again. So let's say you're sending out letters to people in a survey. If a large percent of them don't respond, then that's what we call non-response bias, opposed to volunteer response bias, which is bias caused by volunteers actually responding to it that might have a strong opinion about a subject. Often these two go together, so many times you'll have volunteers responding to something, and you'll have a lot of people that maybe don't care. That's a source of non-response bias. Okay? So it's very important that whenever you're sampling, you're getting a representative population. And to get a representative population, you want to get something where you're not just getting volunteers that are willing to respond, and you're not just getting people and you're also getting everyone that could respond to respond, and that avoids your non-response bias. Next, let's talk about response bias. Response bias is simply any bias that occurs from any part of the survey design that influences responses. So maybe it's the type of question that's asked. The questions may be asked in a way that would influence the responses. For example, if I ask someone, why do you think fast food is bad for you? That already implants in someone's head that fast food is bad for them. Whereas if I ask something like, for example, how nutritional do you think is fast food? That response would be more neutral, or at least the way the question is phrased is more neutral. So people will respond to it in a way that won't lean to one side or the other. You'll get more of the population's true opinion in your sample. Okay. Another thing I'd like to talk to you about is something called the sampling frame. Okay, so I'm going to draw a picture, I think, to best represent the sampling frame, to give you an idea of what it means. So we have the population. So let's say this rectangle represents the population. Okay, and then you have what is known as the sampling frame. Now, the sampling frame so this is the sampling frame. So you have your population. This is what you're trying to get your sample from that's representative of the population. But you also have a sampling frame. The sampling frame is where you can possibly select the sample from. This often changes depending on how you're going to collect the sample. So if the sampling frame covers the population, notice that there's this part in here, and that's covered. The sampling frame in this area that I've semi-shaded in here, that's covered. That's a good thing. Okay, we want this coverage. However, there's a large part of the sampling frame that it does not cover. Okay, this part over here is what we call under coverage. Because the sampling frame is not covering the population. Because the sampling frame is not covering the entire population, whatever is in the under coverage, it's impossible for these elements to be selected from the population. Okay? The part that the sampling frame covers, but the population that we are interested in does not exist, is what we call over coverage. Okay. Overcoverage usually is not as big of a problem as a population unless there's a lot of it. Because what you're going to have is, if you have overcoverage, you're going to have a lot of resources wasted trying to find elements of your population in an area that it doesn't exist. Okay? An example of this is perhaps a phone book. So let's say we want to sample people in Porter County, and you have a list of names in a phone book. Okay, so this is my list of names in a phone book. And I'm only concerned with the people that are in Porter County. So this person might be in Porter County, this person might be in Porter County, this person might be in Porter County. Okay, but these two names, maybe this person, maybe these two people live in LaPorte County, let's say. Well, my phone book has a lot of people that are not in Porter County. We have 2 people here out of these 5 that are in LaPorte County, but I'm only interested in people that are in Porter County. So these names that are in LaPorte County, that's what is known as overcoverage. It's overcoverage because these people in LaPorte County are not in my population, and if I select them for my sampling frame, which is the phone book, then I've selected someone from LaPorte County, and then I can't use them in my sample because they're not a part of my population. My population is just the people in Porter County. On the flip side of things, there's other undercoverage in a phone book. Who's not in a phone book? Well, there's a lot of people that have unlisted numbers, people that I definitely won't call, and so they won't be in the phone book, and that is undercoverage. So anyone who's not in the phone book, which is my sampling frame in this example, is going to be in the undercoverage, and it's impossible for me to select them from the population. Okay, there's two more concepts that I would like to talk about with you. The last concept that really isn't talked about too much in the book is known as a multi-stage sample. And this is something that doesn't come up too often on the AP exam, but I still think it's worth going over. A multi-stage sample is something that occurs when you use sampling techniques with each other. So there's several sampling techniques that you should have read about in section 1.3. There's stratified sampling, there's systematic, there's simple random sampling, there's cluster sampling, okay, and there's also convenience sampling, but that's one that we try to avoid. We also try to avoid cluster usually, but it depends the type of situation, and sometimes we have no choice and we have to do it. But these are the four that you really should know about, especially stratified and simple random sample. I would say those are probably the most important that would be covered on the AP exam. Multi-stage sample is using these sampling techniques together so that you get one sample from the population. For example, let's say I'm trying to get students' opinions on how well registration went this year for the new school year. Well, if I want to get students' opinions on that, then I would probably want to ask people from every grade. So if this represents my population, okay, and there's slightly different numbers, but it's pretty even. We have, so this is my population, and we have 9th grade, 10th grade, 11th grade, and 12th grade. Okay, well, I want to make sure that I get an equal number from each grade. So this is actually a part of a stratified sampling, right? Because it's stratified, okay, I'm actually dividing up my grades, or my population, up into strata, which is the grades. And now I'm going to select individuals from each strata. Okay? But the problem with this is, well, I want to get a decent sized sample. Maybe I want to get, let's say, 100 people from each grade. Well, if I want to get 100 people from each grade, that's a lot of people to just ask individually for how well the registration went this year. So what I can do is I can look at the classes maybe that are going on first block, and I can possibly do a cluster sampling. So I can look at the classes that are going on maybe first block, and I can possibly do a cluster sampling. And maybe I want to take, let's say, this is a class, this is a class, this is a class in 9th grade. Maybe I want to take 3 classes from each grade. But to make things simple, so this is a class during first block. Maybe they're English classes to make things easy. So maybe I'll take 3 full English classes of 9th grade English, 3 full English classes of 10th grade English, and 3 full English classes of 11th grade English. That way I only have to survey 3 classes, so I don't use as many resources to do that. And it's also stratified because I've gotten 3 classes, I've surveyed 3 entire classes from each strata. Okay, this is a multi-stage sample because I'm using multiple sampling techniques together. Okay. The last thing I would like to cover is not actually a sampling method, but it does have to do with section 1.3, and it has to actually do with experimental design. So something in experimental design, and I think they talked about this a little bit in the book, but I want to talk about treatments. Treatments in experimental design are very important. So just for a recap, let's say I have two groups of people. Okay, I'm going to have two groups of people, and they have both of them have the same disease. But this person is going to get a treatment, and this person is going to get a placebo. Remember, the placebo acts like a treatment, and if you want a double-blind experiment, neither the patient, okay, which in this case is the experimental unit, nor the doctor or whoever's administering the treatment knows which one's the treatment and which one's the placebo. That makes it double-blind. But these two people, they have a disease of some kind. One person gets the actual treatment to test to see if the treatment actually works, and the other person's going to get a placebo. Okay? However, you rarely only have one, what we call a level of the treatment. Treatments often get, or people, experimental units that is, treatments often have different levels. So because treatments often have different levels, okay, maybe I'll divide all of the patients that have a disease into 4 groups. So now I'll still have that placebo group, and I'll have 3 treatment groups. And maybe this treatment group only gets 10 milligrams of whatever drug that I want to test. This treatment group might get 20 milligrams, and this treatment group might get 30 milligrams. So these are the different levels that occur in the treatment. Okay. This is something that may come up on the AP exam, but I want you to be aware of it, and it's not often talked about, or it's not talked about in the book. So I thought it was definitely worth bringing it up. Okay? If you have any questions about any of this, feel free to ask me in class.